Hi there and welcome to my channel. In this video we will first solve the problem and then quickly go through the main points to help us solve other similar problems in the future. And so what do we have here? We have the closed interval a to b, and on this interval it's partitioned into n equal subintervals, each of which delta x by the numbers x0 through xn such that x0 equals to a and xn equals to b, and then the rest are in between. And we need to find this limit. Limit as n goes to infinity of the summation I equals 1 to n, the square root of xi, the d delta x. And let's first sketch what this summation is. So this is the x coordinate, x line. And so we have here A, we have here B, and then we have points x1, x2, and x3, and so on. And this is dx, this is dx, this is dx as well. This difference between xi plus 1 and xi. And then for the first, what are the first element of this summation here? It's the square root of x1 times delta x. And then the second term is square root of x2 times delta x. And then the third term, square root of x3 times delta x, plus and so on. So let's see what those are. The first term is delta x times some value square root at the value x1. So this point here is the square root of x1. And so delta square root of x1 times delta x is actually this rectangle here. Similarly, for the second rectangle, we go here for the square root of x2, and this product of square root of x2 times delta x is this rectangle here. And then similarly for x3, somewhere here we have the point which is the square root of x3, and the area is equal to the area. Let's move this here, and the area here, which is again the area of this rectangle. And note one thing here: all these points here, they lie on the curve, which is f of x equals the square root of x. So at this point, we can recognize that this is the right Riemann sum for the function f of x equals the square root of x. And so then as limit goes n goes to infinity, this turns into the integral. So the limit as n goes to infinity of the summation I equals 1 to n of the expression xi delta x, this is equal to the integral, and the limits of integrations here are a and b. A and b, f of x, which is the square root of x, dx. So this is equal to, we need to find this integral, and then that's pretty simple. So we need to recall that integral of x k dx is equal to x to k plus 1 over k plus 1 plus a constant. So this is integral from a to b. Square root of x is x to the 1/2 power dx. So this is equal to This is equal to x to the 3 over 2 divided by 3 over 2, evaluated at points A and B. So equal to, dividing by 3 over 2 is the same as multiplying by 2 over 3. So this is 2 over 3 times plugging in B and A, B to the 3 over 2 minus A to the 3 over 2 power. And so this is our answer. 2 over 3 times B to the power 3 over 2 minus A to the power 3 over 2. Let's go back to our possible answers, and we see that the answer is A. And so what did we learn here? We learned that expression, which is given here as a limit as n goes to infinity of the summation with dx, is potentially a Riemann sum. And so we need to look at what is exactly the function which represents this Riemann sum. And the function is what we have here in the summation sign. And the integral is from A to B, which is given to us here as well. So this is ultimately becomes the limit. Integral from A to B of the function itself. And so we solve this integral, we plug in the endpoints, values, and we find the answer. Thank you for watching. And if you liked this video, please don't forget to click the like button, write me your comments below, and subscribe to my channel where you can find more solutions to the AP Calculus AB and AP Calculus BC problems. And I will see you in the next video.